Okay, this is the video on divisibility rules, Vedic math way. Sutra we would use is by remainders. It's video number W7, a 7th video for a 1-day workshop. Let us continue. Look at outline here. I have two sections, divisibility by first principles and divisibility by remainders. First section is we would look at the first principles applicable for divisibility. Then we would look at section on how to use remainders to decide on divisibility. Okay, let us continue here. Okay, in division we divide the dividend by a divisor, but to get quotient and a remainder. Okay, let's see how problem looks like. We have a dividend. We divide the dividend by the divisor to get a quotient and a remainder. Okay, divisor is like this, is what divides the dividend, and answer is quotient with the remainder at the end. Okay, let's continue here. In divisibility, a dividend is divisible by divisor if the remainder is 0. It's a matter of remainder being 0 or not. Okay, observation, divisibility is matter of remainder being 0 or not. So we'll concentrate in this section more on. Let's look at first principles regarding divisibility. First, 0 is divisible by any number except by itself. Okay? Any number is divisible by itself except when the number is 0 or infinity. Okay, let's continue. A number is divisible by 1. So these are the first principles. We don't have to go do any tests here. Just say 0 is divisible by any number except itself. A number is divisible by itself except when the number is 0 or infinity, and a number is divisible by 1. We are at next section here. We all discussed first principle. Now we would discuss how to use remainders to determine divisibility of a number by divisor. Okay, let us continue here. See testing remainders now. Divisibility by 2. We're going to use the example here. A number is divisible by 2 if it ends in 0, 2, 4, 6 or 8. Okay, that's from multiplication table. The multiplication table for 2, all the entries end in either 0 or 2 or 4 or 6 or 8. Let's continue. Note that 10 is divisible by 2, and 10 divided by 2 is 5, remainder 0. When we divide a number by 10, the remainder is the last digit. Now we need to test the last digit for divisibility, and that's what we did in the previous paragraphs. Okay, we just say ends in 0, 2, 4, 6, 8. That's the last digit was such and such, and we did that because to get last digit we found a remainder by dividing by 10. Okay, so let's continue. Example, is 364 divisible by 2? Remainder is 364 divided by 10 is 4, and 4 is divisible by 2, and so is 364 because 4 is 2 times 2. Example, 7891 divisible by 2. Remember, remainder of 7891 divided by 10 is 1, the last digit, and 1 is not divisible, and neither is. Okay, let's continue with testing remainders. Okay, first we'll discuss here divisibility by 4, and we will see if a number is divisible by 4. Let's continue here. First we note that 100 is divisible by 4 because 100 divided by 4 is 25, remainder 0. What I mean is 100 is a multiple of a 4, and it's actually 24, 5 times 4. Okay, so let's continue here. Then 20 is divisible by 4. That means 20 is a multiple of 4, and in fact 20 is equal to 4 times 5. Okay, let's continue here. First we get remainder from dividing by 100. So what we are trying to do here is from the given number we subtract all the hundreds we can, and whatsoever left over is the same thing as remainder from dividing by 100. So whatsoever we left over is the remainder is the one we are going to use in the next step. Okay, let's continue here. So we'll discard the quotient part of the division. We'll just keep the remainder part. Second, we use that as a dividend for division by 20. What's the remainder I got from first step? I take away all the 20s I can, discard, and that's the same, and see what's left over, this remainder. And it's the same thing as if I divided that remainder here by 20 and discard the quotient and keep the remainder. Okay, we are interested in the remainder only. Let's continue. Third, we check the remainder for divisibility by 4. So first I take away all the hundreds and keep the remainder. Then I take away, from that remainder I take away all the 20s I can and keep the remainder, discard the quotient. And then I see that what's the remainder from second step is in 0, 4, 8, 12 or 16. Or I can take away all the 4s from here and to get a 0. Okay, so the way mechanism here is subtract multiples of the divisor, as many multiples I can, and arrive at a remainder and see if a number we finally arrive at is divisible by 4. And that's the mechanism. We subtract the multiples of the divisor, 4 in this case, as many as I can, as fast as I can, so that I can arrive at a remainder and as quickly as I can. Okay, and so if it's a remainder is in 0, 4, 8, 12 or 16 after I subtracted multiples of hundreds and then multiples of 20s, okay, to get at a remainder which is less than 20. And if that remainder is in 0, 4, 8, 12 and 16, then that number we started with is divisible. Okay, examples. Is 789 divisible by 4? Okay, okay. It's not even divisible by 2, and Tirthaji would say that is out of code, and we don't need to consider that. 789 is not divisible by 4. 789 is not divisible by 4. Let's continue. Is 72780 divisible by 4? Okay, let's continue here. Step 1. A remainder of 72780 is 80. I drew this line here to separate out last 2 digits. Okay, and that's the remainder. This is how we divide by 100. 727 is the quotient and 80 is the remainder. Let's continue. Remainder of 80 divided by 20 is 0. So 80 is, if you divide 80 by 20, remainder is 0, and 0 is divisible by any number. 0 is divisible by 4, and so is 72780. So 72780 is divisible by 4 because 0 is divisible by 4, as 0 is our last remainder. Let's continue. Example, is 56895 divisible by 4? Okay. 56895 is not even divisible by 2, so it's not divisible by 4. Okay. Is 40928 divisible by 4? So we go through the steps. Okay, first we divide by 100 and get a remainder. Remainder of 40928 divided by 100 is 28. The way we divide by 100 is separate our last 2 digits, draw a line to the left, and the number on the left is the quotient, and the one on the right is the dividend, remainder. Remainder is 28, quotient is 409. So remainder is 28. Let's continue here. After that, we take this remainder here and find its remainder when we divide that by 20. So remainder of 28 divided by 20 is 8. Okay, and let's continue. 8 is divisible by 4, and so is 40928. So I went through these steps here, and you could have combined the steps. First of all, look at 28. If you say 28 is divisible by 4, you didn't have to go through the next step here. Okay. Okay? And also you can look at this number here, 40928. We got 28 here, the last two digits, those are remainder. And to divide by 20, take a remainder, this 2 disappear, 2 becomes 0 here. We take 28, 20 out of 28, leaving 8. So you could have said, right from here, it's a 8 would be the last remainder, and 8 is divisible by 4, and so is 40928. So with practice, you will be combining these steps. I have to go through these steps so that you know what is involved. Okay, let's continue. You should be combining the two remainders and write down the final remainder by observation. Take away. Okay, what's what you need to do? You need to combine. Okay, you can combine with practice. You will be divisible by 8. Okay, note that. Let's see what you're going to do. 1000 is divisible by 8. So 1000 is divisible by 8. Let's see what happens. 200 is divisible by 8. Okay, 40 is divisible by 8. So we're going to use these information here, that 1000 is divisible by 8, 200 is divisible by 8, 40 is divisible by 8, and then let's see what happens. So a number is divisible by 8 if the remainder, last remainder of number divided by 40 is in 0, 8, 16, 24, 32. And it's up to you if you wish to go through the steps or combine the steps. Okay, let's continue here. Is 511 300 divisible by 8? Okay, let's continue. First we do remainder by 1000. So 5111 300 divided by 1000 is, remainder is 300. The way we divide by 1000 is separate out the last three digits and draw a line to the left of it. So that's what the one on left 511 is a quotient, and on the right 300 is a remainder. Let's continue. Next step. Remainder 300. If I take this 300 as dividend and divide by 200, and that's remainder is 100. Okay, next three. Remainder of 100 by 40 is 20. Okay, let's continue here. 20 is not divisible by 8, and neither is 511 300. Let's continue examples. Okay, is 5299312 divisible by 8? Let's continue. First, what we do is we find the remainder of the number when we divide by 1000. Last three digits are 312, and that's what the remainder is. Let's continue. Then we take a 312 and find the remainder when we divide that number by 200. That remainder is 112. Okay, next three. Then we divide by 40. Okay, and see a remainder. 112 divided by 40, remainder is 32. Okay, let's continue. 32 is divisible by 8, and so is that number here. So is 5299312. So 32 is divisible by 8, and so is 5299312. Continue here. We can extend the lessons learned so far to determine divisibility of a number by 16. Let's continue. Observations. Step 1. 10,000 is divisible by 16, and subtracting a multiples of 16 does not change the divisibility. So we'll take out all the 10,000 we can, which is division by 10,000, and get the remainder. Okay, then when we take out all the 10,000 we can, what's left is a remainder from division by 10,000, and then we have to worry about if the remainder is divisible by 16. Let's continue. After we've taken all the 10,000s, we take all 2,000 we can, and then what is left is the remainder of dividing by 2,000. The remainder I got from first step, I use that as a dividend on the next step, divide by 2,000, and look at the remainder. We are in doing so, we're trying to take away all the 2,000 we can, and anything we left over is the remainder, and then we need to worry about if that remainder is divisible by 16. Let's continue. Then we know that 4,100 is divisible by 16. Then any remainder we left out by dividing by 2,000. From that, I take out all the 400s I can, and what's left over is the remainder of dividing this remainder by 400, and what's the remainder is, now we need to worry about if that is divisible by 16. Continue. Step 4. 80 is divisible by 16, and any remainder left over from here, from step 3, we take out all the 80s we can, and what's left over is the remainder of dividing that remainder from third step by 80, and what's the remainder left over is, that's what you need to worry about, if that is divisible by 16. Okay, let's continue here. A number is divisible by 16 if the final remainder here from here is divisible by 16. That means that remainder here need to be in 0, 16, 32, 48, or 64. Okay, you can do some exercises. Are the following numbers divisible by 2, 4, 8, and by 16? Let's look at some examples here. Number 9727163, next. 2913452, next. 3046479, next. 1577949, next. 1356582, and some more. Okay, let's continue here. We will check out if a number is divisible by 3. Okay, for that, let's see what to do. Recall from the digit sum discussion, a digit sum is remainder of a number 1 divided by 9. Okay, so we can compute digit sum easily, and that digit sum is in fact equal to remainder of a number when it was divided by 9, with one exception. When the remainder is a 0, digit sum is 9. Let's continue. So what are we going to do? 9 is divisible by 3. Okay. So we need to first take out all the 9s we can from the number, and what's left over would be same thing as remainder of dividing that number by 9. We check that remainder for divisibility by 3. Okay, let's continue here. So let's look at example. Is 1, 2, 3 divisible by 3? First we would take out all the 9s we can from 1, 2, 3, and which is the remainder of dividing 1, 2, 3 by 9. Okay, let's continue. So we're looking for this number here, remainder of 1, 2, 3 divided by 9, and remainder of this is given by digit sum of 1, 2, 3. So 1, 2, 3 digit sum is 6. So if we were to take out all the 9s we can from 123, it would be 6. If we divide 123 by 9, remainder would be 6, and that's given by digit sum of 1, 2, 3. Okay? Now we need to check out, is 6 divisible by 3, and so is 123. So 6 is divisible, and so is 123. Let's continue. Let's continue and discuss divisibility by 6. If a number is divisible by 6, let's investigate it. Note that 6 is a composite number, which by what I mean is that it's a product of 2 and 3. Okay? Let's continue. A number is divisible by 6 if and only if it's divisible both by 2 and 3. So we have to check the divisibility by 2 and also by 3. Okay? Let's continue here. For divisibility by 2, a number has to be even, which, okay, if a number is even, it's divisible by 2. If a number ends in 0, 2, 4, 6, or 8, it's divisible by 2. Let's continue. For divisibility by 3, refer to the previous section, okay, which is check out the digit sum, and then whatsoever that is left over is that remainder divisible by 3. Okay, let's continue here. So let's take an example. 4 to 6, is that divisible by 6? Okay, the two tests we need to do is a composite number. Is it even? It is even. It's divisible by 2. So first test is passed. This test here for divisibility by 2, that passes. Let's continue and see if for divisibility by 3. Okay, let's continue here. Remainder of 426 divided by 9. So we're going to take out all the 9s we can, and whatsoever is left over is remainder from dividing 426 by 9, and that is 3 from the digit sum. Okay, and that 3 is divisible by 3. So we passed the first test of divisibility by 2, and we passed the second test of divisibility by 3. Okay, so that means 426 is divisible by 6. Let's continue. Okay, now let's discuss divisibility by 9. For divisibility by 9, remainder from division by 9 has to be 0. That means when we take away all the 9s we can, the leftover should be 0. Okay. Recall from digit sum discussion, when the remainder from division by 9 is 0, digit sum of that number is 9. Okay. Let's continue. A number is divisible by 9 if it is digit sum is 9. So from this discussion here, we know that if a number is divisible by 9, if its digit sum is 9. Let's continue. Let's look at an example here. Is 234 divisible by 9? Let's continue here. So when we take away all the 9s we can from 234, it's the same thing as dividing 234 by 9, discarding the quotient and keeping the remainder. And that remainder is also given by digit sum of the number 234. Digit sum of 234 is 9. Okay. And we say that if a if the remainder is a 0, the digit sum is 9. So digit sum I get 9, so it's a divisible by 9. That means 234 is divisible by 9. Let's continue. For exercises, refer to the digit sum section. I gave a link already in the previous pages. Continue and discuss divisibility by 5. Okay. Divisible by a number is divisible by 5, it ends in either 0 or in 5. Okay, let's continue here. So let's see what we did. We are doing by remainder. So 10 is divisible by 5 because 10 divided by 5 is 2 remainder of 0. That means 10 is equal to 2 times 5. That means that we would try to take away as many 10s as I can and as fast as I can from the number. What's left over is a remainder. It's the same thing as if I were to divide a number by 10, like divide 10 and discard the quotient and keep the remainder. We need to check that remainder for divisibility by 5. So that remainder what's left over is there are only two single digit numbers divisible by 5, and those are 0 and 5. In fact, as soon as when I start taking tens away, as soon as I can decide that number is divisible, I don't need to take away anymore. But if I need to continue to see if the remainder is 0, I can subtract 5 from this 5 here and also get a 0. So, but we know that 0 is divisible by 5 and so is 5, and I don't need to do any more subtractions. Let's continue. Example, is 6896 divisible by 5? Let's continue here. First step is we're going to take away all the 10s we can. Okay. And the way we do that is 6896, and we get dry line to the left of a 6 here, and the one on the left is a quotient, the on the right is a remainder. Remainder is 6. Okay. Let's continue. 6 is not divisible by 5. It's not in this list, in the set of 0 and 5. So, and neither is 6896. Another example. Okay. So what's the largest number having one occurrence of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 each, such that it's divisible by 2, 3, 4, 5, 6, 8, and 9. Let's continue here. Largest number with all these digits is largest digit on the left and smallest digit on the right, and in this descending order. So 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is largest number consisting of one each of these digits we had in mind. Okay, let's continue. Is this is divisible by 2. First check its digit sum. Its digit sum of the number is 9. So and it's even. So it's divisible by 2, 3, 6, and 9. It's also divisible by 5. Okay. Okay, let's continue here. To make the, but it's not divisible by 4. Okay, because 10 in the last two digits is not divisible by 4. But if I change that to 20 by interchanging 21212, then that's divisible by 4 also. Let's continue here. That number is now after the exchange here 9876543 instead of 210 we have it now 120. Let's continue here. Now this number is divisible by 2, it's even. Divisible by 3 is digit sum is 9. It divisible by 4, where the last two digits are 20, which is divisible by 4. 5, it ends in a 0. 6, it's even and digits sum is 9. 8 is 120, the three digits in the right are divisible by 8, and a 9, its digit sum is 9. So, okay, let's continue and discuss divisibility by 11. Okay, recall that we use digit sum for a number to obtain a remainder from dividing by 9. Okay, let's observe here. 9 is 1 less than 10 and we added the digits. Okay. 11 is 1 more than 10 and we need to subtract the digits in some way. Okay, let's continue here. I'm going to define a term called digit difference. I have not seen the term in any of the books I have looked into, and I'm going to define that as difference, but it's continued difference of digits in a number is its digit difference. So digit sum was sum of the number, and digit difference is difference of the digits in the number, but it's a continued difference. And the digit difference is the remainder from division by 11. So digit sum is remainder from division by 9 here, and digit difference is the remainder from division by 11. And we use next slides to explain what I mean by the digit difference. Okay, I have not seen the term in any of the textbooks I have seen. Okay, let's continue here. Let's look at the digit difference. First, we considered a number. Number is a linear combination of the natural base numbers. Natural base numbers are power of 10, and this is the multiplier for linear combination. We are looking at integers only. A is integer, and smallest value of I is 0. Okay, let's continue. And I define digit difference of which dd is a0, the first coefficient, minus parenthesis second coefficient a1 minus parenthesis next higher coefficient a2 minus parenthesis a3. Now let's sort them out. So a0 is positive. Okay, a1 has a minus here is negative, so minus a1 is in the parenthesis after the minus sign a1. A2 is positive, minus and minus make it positive. A2 is positive, but A3, 1, 2, and 3 minuses. So A3 is negative. So these are the coefficients of the even terms. Even terms mean terms which of the even power of 10. Okay, and these are the odd terms. Those are the coefficients of the odd power of 10. Okay, let's continue here. So let's look at number line again from starting from 1 and compute their digit difference using this equation here. Okay, 1 single digit, nothing to subtract from, it's a 1. 2 single digit, 2. 3 single digit again. 4 single digit again. 5 single digit again. 6, 7, 8, 9, 10. Now we got 2 digits. Okay, 10 is 2 digits. This is A0 is a 0 and A1 is a 1. So we got A0 minus A1. Digit difference is minus 1. Let's continue with 11. We got 1 and a 1. 1 minus 1 is 0 and 0. So in digit sum, we could not get a value of a 0. In a digit difference, because we were adding that time. Now we are doing some kind of subtractions here. So because 0 I can have, no problem with 0. 12 is a 1. So 2 minus 1 is 1. We started with 1, we came back with 1, and we repeat. So this is a period here and repeats after on 12th term. Okay, and period is 11. So this dd is periodic and a period is 11. So digit difference repeats after 11 entries. So period is 11, and one can resolve minus 1 now. Replace minus 1 by minus 1 plus 11, which is equal to 10. Let's continue. Okay, so digit difference of 10 was minus 1, which we can replace by 10. Okay, let's continue with 13. Digit difference is 3 minus 1, which is 2. With 14, it's a 4 minus 1, which is 3. 15 is a 5 minus 1 is a 4. 16, it's a 6 minus 1 equals 5. Okay, and you can verify for yourself that numbers in the digit second row are remainder when a corresponding number in the first row is divided by 11. Okay? So dd of number is remainder when number is divided by 11. Okay, when a digit difference is more than 10, we repeatedly compute digit difference to arrive at a number in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's continue. Again, when digit difference is less than minus 10, repeatedly compute digit difference again. And if the digit difference obtained so far is negative, add 11 to make that positive. Okay, and then it would be in this from 0 through 10. Let's continue. Now, divisibility by 11. A number is divisible by 11 if digit difference of that number is 0. Okay, a number is divisible by 11 if its remainder when we divide it by 11 is 0, and we already figured out that when remainder is a 0 and so is a digit difference. Okay, let's continue and have some examples. Example, compute digit difference of 3453. Let's continue here. So that means 3 is A0 and A2, 3 plus 4 and minus A1, which is 5 and 3. So 3 plus 4 is 7 minus 5 plus 3 is 8. So it's 7 minus 8, which is minus 1, and minus 1. Then we can add the period to it. Minus 1 plus 11 is 10. So digit difference of 3453 is a 10. Okay. We did not have to redo the digit difference after of 10 because we have a reasonable number which is between 0 and 10. Let's continue. Let's do another one. 3453 and divided by 11 is 313, remainder 10. So remainder is 10, and that was digit difference. That verifies that even in this example, the digit difference is same thing as the remainder of when we divide by 11. Okay, let's continue. Do another example here. DD of 24867. Now we have 5-digit number. Okay, that means let's see what's going on here. So for positive terms are 7, 8, and a 2. 7 plus 8 plus 2 is 17, and negatives are 6 and a 4. So it's 17 minus 10, which is 7. Again, I don't have to redo the digit difference because digit difference obtained so far is 7, which is within 0 and 10. Okay, let's continue. And if you did divide by 11, which is 2260, remainder 7. This remainder 7 still matches with the digit difference 7. So it still verifies that digit difference is the remainder when we divide by 11. Some more examples. Example 1. Digit difference of 1, 2, 3. It is 3 plus 1 minus 2. 3 minus 2 plus 1, which is 2. Okay. Okay, and if you divide 1, 2, 3 by 11, it's 11 remainder 2. So this digit difference still matches with the 2 in this example also. It still verifies that our assumptions that digit difference is equal to remainder when number is divided by 11 is still holds. Okay, it's still verified. So let's do another example. Digit difference of 5752212, which is equal to 2 plus 2 plus 5 plus 5. 2 plus 2 plus 5 plus 5. It's a 4 and a 10. 14 minus this minus side here. 1 plus 2 plus 7. 1 plus 2 plus 7 is 10. So that is 4. 14 minus 10 is 4. Let's continue here. Let's look at the, if we divide 5, 7, 5, 2, 2, 1, 2 divided by 11, I do get remainder 4. So digit difference still verifies that it is equal to remainder. Remainder is 4, so is the digit difference. Let's another example here. 3. Digit difference of 8, 8, 6, 1, 0, 2, 3. Let's continue here, which is equal to 3 plus 0 plus 6 plus 8. 3 plus 0 plus 6 plus 8, which is equal to 3 plus 6 is 9, plus 8, 17, and minus 2, 1. 2 plus 1 is 3, and 8, 11. So it's 17 minus 11 is a 6. Let's continue here. And it still matches. 8, 8, 6, 1, 0, 2, 3 divided by 11 is 8, 0, 5, 5, 4, 7, remainder 6. Remainder 6 still verifies and matches sizes now. Okay? Let's find the remainder from dividing the following by 11. Let's continue here. First number 4233960. Let's continue. Next 703210. Next number is 8916812. Next number is 3703887. Next number is 575973, and some more. Now discuss division by composite numbers. Let's see what composite numbers are. Composite numbers. A composite number is product of other numbers. For such numbers, divisibility test requires divisibility by its components. We have already seen one such test when we were discussing divisibility by 6. 6 was 2 times 3, okay? Product of 2 and 3. Let's continue here. Okay, so divisibility by 12. 12 is 3 times 4, and number needs to be divisible both by 3 and 4. For a number to be divisible by 12, it has to be divisible both by 3 and 4. Let's continue. Number 15. 15 is 3 times 5. For a number to be divisible by 15, it has to be divisible both by 3 and 5. Let's continue. Divisibility by 18. Note that 18 is equal to 2 times 9. For a number to be divisible by 18, it needs to be divisible both by 2 and 9. Exercises here. Okay? Are the following numbers divisible by 12, 15, 18, 22, and 24? Let's continue. First number 806657. Next number 82019. Next number 531688. Next number 720865. Next number 28833, and some more. Up summary now. We're now going to summarize the by remainder method. Let's see what's going on here. Okay, in teacher's manual, Vanna Singh's book and Glover's book cover the issues discussed here in some form or the other. Okay, let's continue. Okay, the books do not recognize that these are using remainders, and that is within the spirit of Vedic math, which is of short and sweet one-line mental solution. In Vedic math, we skip details and combine steps. Okay, let's continue here. With practice, you would be combining steps and skipping details too. That would be your second nature. This method is a direct method, and you arrive at a remainder by subtracting multiples of the divisor. Okay, let's continue. Some references you can use. First, Vedic Math Teacher's Manual, Elementary Level by Ken Williams is a decent reference. The book is available for purchase in print form or for free in PDF form from vedicmaths.org. Hindi edition is also available in PDF form. Vedic Math by Bharati Krishna Tirthaji is the original reference on the subject. Vedic Math for Schools in 3 volumes by James T. Grover. Mr. Grover uses these books in his school and they are very readable. Vedic Math Made Easy by Dhamal Bhatia is readable too. And Vedic Math for All Ages is a decent book by Vanna Singhal. Okay? You can also use this link here for divisibility rules in Wikipedia. That's all for this topic.